the problem solution, why Kafka, and then what can be the best use cases for using Kafka, a high level architecture of Kafka. Hey, what happened? I'm still sharing the screen, correct?
Yeah.
Okay. And then pull-based approach, Kafka architecture, features and terminology. Maybe someone can mute. Okay. And then there are a few use cases where Kafka can be used on the video streaming platform, and on how we can use it on the e-commerce like Amazon, Flipkart, or Facebook, Google Maps, Airbnb, notifications service system, Twitter, Ola, Uber, WhatsApp, or FB Messenger, Zooms, or video conferencing. So these are kind of a like very high systems having a huge data and volume. So maybe one or two we can pick up for today. I may not be able to cover all those use cases today, which we can keep for our subsequent session. Fine. So we'll see. So the fundamental is you're having a source system, and then we need to talk with the target system, and we need to have a data. That looks very simple. But now what happens after a while when the companies grow, organizations grow, the application has to be develop, enhance in that way. And then you will be having a multiple source of system. Now, once you will be having a multiple source of system, you will be having a different target system also, then the complexity is going to increase at this point in the venture. Why so? Just take example, you're having a source system, and then you can have six target systems. So altogether, 24 integration has to happen. For this 20, we need to write 24 integrations, and then the difficulties around will be on the protocol, how data is transported. You're going to use the TCP, HTTP, REST, FTP, JDBC, whatever is there, you need to have a protocol for that. Then the data formatting, how data is passed. Either you want to go for a binary, CSV, JSON, or Avro. And then for a data scheme and evolution, how the data is shaped, and it may change also. So each source system will have an increased load from the connection. Now that is the problem. And the solution for that is this Apache Kafka. Okay. Where for your multiple source system, it is going to decouple your data streams and system. Now your source systems can talk to Kafka, and in turn your target systems can get data from the Apache Kafka. Okay. Now, example can be, so you're having a website events, you can have a pricing data as a source system, you can have a financial transactions or user interactions. All those goes to the Kafka. And then from there, it can talk to the database, the same data. The Kafka consumer can be for analytics or for email systems or for auditing purpose. And then there can be multiple uses of that. I will go a little fast to keep it just to the point, but yeah, you can just note down your queries and then we can take it later. Okay, so now why Apache Kafka? So it is created by LinkedIn, and now it's open source product mainly maintained by one company which is Confluent, and it is distributed. It is having a resilient architecture. It's fault tolerance. And then it's having the horizontal scalability, where you can scale to hundreds of broker, and you can scale to millions of messages per second. It's having high performance, so latency of less than 10 milliseconds in the real time you can get, and it can be used by many firms. Almost top 35-40% of Fortune 500 organizations are using Kafka, say Airbnb or Netflix or Uber, Walmart, LinkedIn, and many more. So let's talk about the what are the best use cases of Kafka. So Kafka provides you the broker itself and has been designed towards stream processing scenarios. So recently it has added the Kafka streams, which is a client library for building applications and microservices. So this Kafka supports use cases such as matrices or activity tracking, log aggregation, stream processing, commit logs, and event sourcing. So in this scenarios, whatever I have mentioned here, you can use it where the streams with complex routing, where throughput can be of 100 thousands per second, and for events or more, with at least one partition ordering. So whenever we need to have application which requires a streams of history streams, that time we can know use it where it will be delivered at least once, and with the partition ordering, client can see a replay of those event stream. So it can be used for event sourcing, modeling changes to a system as a sequence of event, and then this stream processing data can be used in multi-stage pipelines, and these pipelines can generate graphs of real-time data flows and all those things. And then obviously you can integrate with the Spark and Hadoop and many other big data technologies. And in some of the use cases, which I will be showing you in the subsequent slides, where we can see how it has been integrated with Spark, Hadoop, and other things. So for if I talk about here, why Netflix is using Kafka is mainly to apply recommendation in the real time while you're watching the TV shows. Uber uses Kafka to gather user taxi and trip data in real time to compute and forecast demands, and it will compute the search pricing in real time. Likewise, if I talk about LinkedIn, it uses Kafka to prevent spam. It collects user interactions to make better connection recommendation in real time. So just remember that Kafka is only used as a transportation mechanism. So let's talk about a high level architecture of the Kafka, where you can see the producer, consumers, and then you will be having a Kafka clusters with the topic and partitions. So producers and consumers are the same here, applications that publish and read event messages respectively. So uh, we'll be seeing in the Kafka use cases that an event is a message with data, which describes the events such as new user signing into a mobile application, or events are queued in Kafka topics, and multiple consumers can subscribe to the same topic. Those topics are further divided into partitions, which splits data across brokers to improve performance. So it is a pull-based approach, whereas you might have seen the earlier when we used to use RabbitMQ, which was push-based approach. Here, when we say it is a pull-based, so Kafka uses a pull model where consumer request batches of messages from a specific offset. And then Kafka permits this long pooling, which prevents type loops. When there is no message, it passes the offset, and aggressively it batches messages to support this. So pull model is a logical for Kafka because of the partition data structure which it uses, and it provides message order in a partition with no contending consumers. So this allows users to leverage the batching of messages for effective um, message delivery and higher throughput. So if I tell you about some feature of Kafka, it is very high volume pub sub message and a stream platform, which is very much durable, fast, and highly scalable. And when I say it is a durable message stores, it behaves like a log which runs in a server clusters, which keeps streams of records in topics, or you can say it as categories. And when I talk about messages format, messages are made up of a value, a key, and a timestamp. And it can use the dumb broker or a smart consumer model, which is that it does not try to track which messages are read by consumer and only keeps unread messages. So Kafka keeps all the messages for a set period of time. Default will be 1 week. And it is managed by external services. In many cases, you will be seeing it as Apache Zookeeper, which is going to manage it. There are some terminology. Let's understand what are topics, partitions, and offset. So a topic is a particular stream of data. It is similar to a table in a database without all the constraints. So you can have as many topics as you want, and a topic is defined by its name. And further, topics can be split into partitions, and then each partitions will be ordered, and each message within the partition gets an incremental ID, and we call that incremental ID as offset. So in this example, you can see partition 0, partition 1, and partition 2 is there. And then from the partition 0, you can see the offset as 0, 1, 2, 3 up to 10, 11, 12, and so on. Whereas in the partition 0, whereas in the partition 1, you can see it is from 0 to 8. So all these partitions are independent of each other. Likewise, in the partition 2, you can see it is having an offset from 0, 1 to up to 10. Okay, so let's see what are the topics, and let's take one example of topic as a in our TMS system where we are having a multiple trailers or a trucks. So say you have a fleet of trucks and each trucks reports its GPS position to Kafka. Okay, so you can have a topic with the name as trucks underscore GPS that contains position of all the trucks. So what is going to happen is each truck will send a message to Kafka every 20 seconds. And each message will contain the trailer ID or truck ID and the truck position, which means the latitude and longitude. And we can choose to create that topic with 10 partitions, which is just an arbitrary number. And then the same thing can be consumed to the different consumers. Say the user may have a location dashboard where you can see it, or you want to send it for the notification service. So there you can use this. Okay, let me go back to the previous slides once again. Coming to again the partition and all. Okay, so let's talk about offset. So offset only have a meaning for a specific partition. For example, so offset 3 in a partition 0 does not represent the same data as offset 3 in partition 1. Okay, so this are you seeing my cursor also? Is it moving?
No.
No.
Oh, I'm not sure what is the option to do that over Zoom. I can do quickly. Anyone knows how I can show my cursor?
But anyway, I think you're talking about the number 3 in the partition, which is the offset, right?
Yes.
You're telling the data is not same across.
Yes, correct. So yeah, just try to imagine wherever I am going. So yeah, so and the order is guaranteed only within the partition, not across partition, which means the offset 6 in the partition 0 and offset 6 in the partition 1, both of them may have a different data. And then which one came first, we also don't know. So order is only guaranteed within a partition, not across partitions, which means the offset 6 in the partition 0 may be first, or the offset 6 on partition 1. So we don't know that. So, and again, as I said, the data is kept only for a limited time. That is default to 1 week. And once data is returned to a partition, it cannot be changed. That is very important thing, which means immutability. And if you want to have new data, then you have to write it after 8 in partition 1. You cannot change the offset 6 or 7, which is written once. And data is assigned randomly to a partition unless the key is provided. And we'll see that more on that. So maybe let's talk a little about broker. What is broker? So a Kafka cluster is composed of multiple brokers, or we can say it as server. And each broker is identified with its ID. Mainly it will be integer. And each broker contains certain topics, topics partitions. And after connecting to any broker, which we call it as a bootstrap broker, you can connect to the entire cluster. That's how I will be explaining you. So a good number to start is to start with a 3 broker, but no, someone can have a big cluster where you may have more than 100 brokers. So if you see why I delivered that statement that no, if you are connected with just one broker, also you can virtually connect it to the entire cluster. So if I see this broker 1, broker 2, broker 3, in broker 1 and broker 2, you can see that we are having a topic 1, partition 0, topic 1, partition 2. But in broker 3, you don't have a topic 2. Okay, so if we want to get a topic 2, then we need to come to the broker 1 or broker 2 only. So if we search for a topic 2, ultimately, if you connected with one broker, you can connect it to the entire cluster. So so many slides at once. And that is the reason why this thing, which is known as replication factors, come into the picture. Let's take example. We'll consider the last example only, where we are having example of 2 topics with 3 partitions and 2 partitions. So data is distributed and broker 3 does not have any data for a topic 2. So for the same reason, we will be having this replication factor, which says how our data is replicated, or how many copies we are having. So topic should have a replication factor, usually more than 1, usually in between 2 and 3. This way, if a broker is down, then another broker can serve the data. Example say, suppose with the topic 2 partition and a replication factor of 2, uh, in case this broker 2 goes off, then also you will be having data into the another broker. So that's why we try to have at least replication factor of 2, so that if we lost uh, broker number 2, the results can be from broker number 1 and 3 can serve the data. So let's talk about partition. So at any given point of time, you will be having a one broker that can be act as a leader for a given partition. Okay, and only that leader can receive and serve data for a partition. The other brokers will synchronize the data, and there each partition has one leader and multiple ISR. ISR is nothing but in sync replicas. So always in the replication factor, when we talk about, we used to have a one leader. I won't go much into detail in this fundamental session. Maybe we can jump to one of the examples where no, for video streaming platform like YouTube or Netflix or whatever, we can see how this Kafka can be used. I'm not sure whether it is fully visible to you guys or not. Let me try to explain it quickly. I mean, for today, maybe we can just take this example, and tomorrow or in our subsequent sessions, I do have other examples. Like I will just quickly show you for Amazon, Flipkart, how the Kafka can be used, for Facebook, how I can use it, for Google Map, how I can use, for Airbnb, how it can be used, for notification service, with a big bulky notification service, you can see 3 streams of Kafka server I'm having. And then same way for a Twitter also we can use it. For Ola, Uber we can use. For WhatsApp or FB Messenger we can use Kafka. For Zoom platforming or any video conferencing thing, if we are using there also we can use Kafka. So my intention for showing this system to you guys is, again, don't quote me. It may not be the exact thing what YouTube might be using, but just for our understanding, let's see what is happening. So whatever, just a color convention, whatever you are seeing it in green, those are applications or the websites or the users or the clients. Whatever you're seeing it in the red color, that can be your databases or this where you're going to store it, or the third parties. And wherever you're seeing it in the blue color, those are the REST services, or it can be the Spark jobs for Kafka consumers. And whatever is in the black color, that is your load balancers and other things, authentication, authorizations, all those layers will go there. So I will be starting it from the left. I wish you guys can see my mouse, but no worries. Let's try to see from the left. So say suppose it is a YouTube applications where no you are having a content creator, the creators who will upload their videos or podcast, and uh, after going through the load balancer, there will be a service which is known as asset onboarding service. Now that asset onboarding service will be using data, NoSQL data, that is a Cassandra cluster, say, suppose we are using, and then the actual data it is going to use in the Amazon S3 bucket for storage. And the moment any video has been uploaded, that notification as a Kafka consumer, it will go to the Kafka. And then from the Kafka, you can see in the right-hand side, you're having a search Kafka consumer. So from that search Kafka consumer, it will go to the Elasticsearch cluster. And then when you see here in the right-hand side, right bottom down, where you are seeing in the green users on the home page or a search page where they are going to search anything. So if the video has been uploaded, that thing no can be visible with the home page service or a search service. So the search service and homepage service will be using, say, suppose this Elasticsearch clusters, and which is nothing but a Kafka consumer, search Kafka consumer. Let's take another example. Now, before processing this video, in the extreme left side, you can see a content processor where you're having a workflow engine. So you will be having a big file chunker. So they're going to chunk the files. You will be having a content filter for privacy or trafficking. Then you will be having a content tagging, classifiers, thumbnails, and all those things. Transcoders will be there. Uh, no, where the different formats you're going to use, and you're going to upload all the videos to the CDN or S3. And then from there, it goes to the CDN and then to the different states. So what is going to happen is uh, the moment any content is been processed, again, that message will goes to the Kafka. And from that Kafka, it will go down to the CDN writer. You can see in the middle downside, that is the CDN writer. And then from the CDN writer, it will go to the CDN optimized for the local viewing, where no user can actually see that content on their device. So that's how the entire thing works. Again, you will be having an asset service. So you can see in this example itself, you're having a multiple consumers and producers of the Kafka. So user informations, we can save it in the user service with Redis clusters, which can be used for only for the active users which are there, and the main database can be your MySQL clusters or anything like that. So again, from the Kafka, what is going to happen is you can send it for a notification Kafka consumer. And as I showed that there is a big notification systems where you can integrate with it with SNS or the email and other things. And then the same thing can be goes to the Apache streaming cluster, that is a Spark, and then it goes to the Hadoop where you can have a map reduce and all those things. And then finally it goes for recommendation and traffic predicting systems for Apache Spark clusters. And then from again, it will save those things into the cluster Cassandra, and then it goes to the homepage servers. So that's how you can see the backbone of the entire system here in middle, that is a Kafka. Okay. So yeah, we are almost half hour done. I will take a pause here because I don't want to rush. And then there are other systems which we will see slowly in the maybe the upcoming sessions. I can have one or two more sessions on that, and we can go deep into that. But we'll take a pause here for any questions, any queries which you guys are having.
I had a question, Sagar. So basically, all the components that we are seeing there, like apart from Amazon S3, the CDN or Kafka, are those Amazon managed services? Is that what was visualized in the architecture diagram?
It can be any. It can be anything. So S3 bucket is from the AWS, which you can use, but
Yes.
it's independent of the things which you can use. Yeah, there is one more thing which I would like to share with you. Okay, let me reshare the PPT once again. Just a minute. Mhm. Where is my Teams? You see the chat. Okay, yeah, sure, got it. So what you guys can do is, as a, you can say it as an assignment or something. Are you seeing my entire, I think you're seeing my entire screen. So I will be pinging this to link to you. This conflict company, which is now maintaining the Kafka. You can go to their sites by following this link, https://developers.confluent.io, learn Kafka, where you will be seeing many videos. And then there is one more link which I will be sharing with you. That is a kafka.apacheorg, which is a quick start. So if you are going to go there, you can watch this 10 minutes of no introduction video with them. And then quickly, let me share one more thing with you. Yeah, I'm really sorry. My net is sorry. My system is performing really. Sorry, I just want to share my browser. Okay, almost there. Yes, are you seeing my Firefox now?
Yeah.
Yes.
Okay, fine. So I will be sharing this link with you over the Teams chat, where you can go to this website, which is kafkaapache.org. Quick start is there. Just watch this 10-minute of video as your assignment. Go to the step number 1, download the latest Kafka release and extract it. And once you get the Kafka, you need to start your Kafka environment. Usually you can do with a Zookeeper or Kraft, any one of them. Follow one step. If you are having a MacBook, you can use this .sh command, or for a Linux or Windows, similarly, you can get
Sagar,
something.
sorry to interrupt. I think it is better to do with Kraft because Kafka has abandoned Zookeeper, I think 2-3 years ago.
Okay, sure. Sure, you can go with Kraft. And then you can create a topic to store your events. So there are 7 steps which you yourself can go through, and if the time permits, we can also go through it. But I will be just sharing this references to you, where no, you can write some event into the topic, then you can read the events in the step number 5, then you can export your data as a streams of event with Kafka Connect, and then there are different commands for Windows or Linux, Unix systems. And that's how you can have your first Kafka application up and running. Okay, so it's a quick 10-15 minutes of job. So just to do it. And then there's a lot of videos you can see on this developer Confluent Learn Kafka. 1 hour 35 minutes for a basic foundation course, and you're having a Kafka stream around 2 hours. Kafka Connect is there. Spring, if you are using Kafka, then you must watch this video, Spring Framework with Apache Kafka, and how the internal architecture works for Kafka. You can watch this. All this, there are a lot, good amount of tutorials already available. So with the self-help, you can go through it and just watch it. So my intention for having this session was just to understand some terminology and wherever it can be used. So I will promise we'll have one more session where I would like to go through those system designs where the Kafka is being used, and then that will give us one more edge to understand wherever in real life, in real applications, this Kafka has been used, and then we can get some idea how we can implement into our project as well. Okay, we are good then.